Hey gang, had a technical glitch. Uh, I won't even go into that. Uh, anyway, where I left off was we had just calculated the sum of squares total, and it was 407,985.9. And we were focusing on the calculation for the sum of squares error. And the sum of squares error, as you'll find out, very easy to calculate for even a large data set like this, because really all we do is we just take each observation in each cell and subtract it from the cell mean and square that up. So guys, in our situation here, we have traditional instruction across male and female, and we have dual credit instruction across male and female. And we saw that the mean in each of these cells uh, 104 and 116. And I think I left you with, because there was such a discrepancy, a difference, pretty wide difference between the mean points for female across tradition and the mean points across dual credit for males, that I'm thinking that the interaction is probably going to be statistically significant, but we're just going to let it play out. Now, something I want you to focus on here is if you look back at our original data set, you can see that cases 1 through 200 were traditional female, right? And from 201 to 400 were traditional on-campus male scores. From 401 to 600, we had dual credit females. And from 601 to 800, we have dual credit males. Now, guys, keep that in mind, because what I'm going to do is I'm going to set up some new data frames over in R. I'm going to show you how to do that here. And it's going to help us come up with our, again, the game plan here is we come in for the first 200 subjects. We take the number of points subtracted from the mean, square it up, observation minus mean squared, do that for all, first 200 observations for this particular cell, for this particular mean. And then we'll come over here to the 201st, all the way down to the 400th observation, subtracting it from 148. So, again, how do you talk R into doing that? Well, the way I do this is I set up, first thing, let's just recall that we can we can get our group means like this. All right. Now, I'm going to tell you, I'm expecting a package, and I think I may get interrupted. But if I do, I'll just pause and take off. All right, gang. What I want to do is I want to set up 4 what I call data frames, and I want to call the first one. I think the first 200 were traditional female. So I'm just going to call this TF for traditional female. And I'm going to use what's called a data function. Now, whatever I call my data set back up here, this is what I have to call this function. I come in not with parentheses, but with braces. And I want to select, let me show you what's going on here. So think about in this command, we name our data set, and what we put in the first place are the cases that we want to select in creating this new data frame, this new subset of our original data. And the second part, we want to choose the variables. So I have 1, 2, 3 variables. I got rid of ID for a reason I won't get into. But I want to keep all those. So what I want to do is I want to go from 1 to 200. And then I'll leave this blank telling the command that I want to keep all of my variables. The next thing I want to do is my traditional mail. And here I want to select the cases 201 to 400. Next thing I want to do is dual credit female. And I want to choose the cases 401 to 600. And then I want to do dual credit male. And I want to choose my cases 601 up to 800 with all the variables. All right, now what I've got to do to get R to focus, for example, on the first two, I have to attach the data set called TF. Now I want to come in and do some multiple commands, and this will make sense in just a second, or at least I hope it will. I want to attach it, but then I want to do some stuff. So I'm going to call this command X, and what I want to do is I want to take the points in that particular data frame, just for the first 200 subjects, minus the mean of the points just for those, and I want to square those. And then I want to come in and do a sum of X. Now, what I'll do there is I'm going to create over here my sum of squares for each particular group. So I have traditional female, which is 52,684. Now, gang, all I have to do is go up, and I want to come in and choose traditional male. I want to do the same thing, so all this other stuff is going to be calculated according to just the IDs from 201 to 400. So for this, I get a sum of squares of 58,192. Go up. I want dual credit female. So it's 50,762. 196. And go up, and the thing I want next is dual credit male. And it's 31,090.88. You guys think on your midterm that you will be calculating any sum of squares for a particular group? Yes, you will be. I'm really not in the the habit of giving out exam questions, but I just did, right? So 52,684 plus 51 or 58,192 plus 50762. 0.96 and 31,090.88. All right, gang, so we get a sum of squares error of 192,729.80. All right. Now, guys, we started this crazy mess by telling you, I told you that we're going to examine the error decomposition. And we're going to do that by taking a look at the sum of squares total, which is broken down into the sum of squares for factor A, sum of squares for factor B. In this problem, sum of squares factor A is for gender. This is for group, instructional technique. All right, now what I know from all of my hard work is that the sum of squares for a gender, was 45,030. The sum of squares for instruction was 168, 432. The sum of squares for the interaction I didn't calculate. The sum of squares for the error I just calculated and I've lost it. It's 192, 729.80. And guys, my sum of squares total was 407,985.9. So gang, we can see that the sum of squares for the interaction is going to be, let's see, 407,985.9 minus 45,030 minus 168,432 plus 192,729.8. So, guys, sum of squares for the interaction is, it doesn't seem right. So 407,985.9 minus 45,030 minus 168,432 minus 92,729.8. So 1794.1. All right, guys, hold on. My dog's losing her mind. All right, guys, I'm back. All right, so what we get into next is we get into our degrees of freedom. And our degrees of freedom break down this way. Our degrees of freedom, we'll just look at the main effects first. So for our first, it's just a minus 1, where a is the number of groups in factor a. A dog wanted in so bad, and then she just went back out. Degrees of freedom for factor b is just b minus 1. The degrees of freedom for a cross b is just a minus 1 times b minus 1. The degrees of freedom for the error is my total sample size minus AB. So guys, when you do the math, take a minus 1 plus b minus 1 plus AB minus AB. I'm sorry, AB minus A minus B plus 1 plus N minus AB. You end up with N minus 1 as your degrees of freedom for your total. So, gang, what we can do is we can now get an indication of our F statistic, and I'm not going to go through this for every one of them, but what I'll do is go through some of it, go through one illustration. All right, so for A, and then I want to come down to my error. So I know I have a sum of squares for A of 45,030. And of course I could do this for B and A cross B. And my error term was 192,729.8. 729 0.80. My degrees of freedom. Group A is gender. I had 2 groups, so my degrees of freedom are 1. And my degrees of freedom for my error would be my total sample size 800 minus A times B is 796. Okay, mean square will be 45,030 divided by 1. And 192,729.8 divided by 796. Guys, can't do that one in my head. 192, 729.8 divided by 796. So I get 242.123. Let's call it. Now, to calculate the F statistic here, the F statistic for our main effect, interaction effect is always calculated the same way. It's the mean square for the term divided by the mean square for the error. So if I take 45,030 divided by 242. So I have 45,030 divided by 242.123. I get an F statistic of 185.98. Next thing is my p-value. My p-value is going to be calculated by a function that we call PF. Now I can't remember. I've got to tell you, it's either PF. Actually, I think it's this right here, where we put in 3 things. And this will give us, in the F distribution in R, it will give us the area below. But guys, remember, the p-value is the area above, so we're going to have to make, well, we have to subtract from 1. Here we put in our F statistic. Here we put in our degrees of freedom for the main effect that we're calculating the p-value for, and here we put in the degrees of freedom for the error term. Now, I go over to R, and I'm going to go 1 minus PF, my test statistic, comma my degrees of freedom for my term, and my degrees of freedom. And you'll see that I get a very, very, very small number telling me that my main effect of gender is statistically significant. There is a difference between scores, not broken across dual credit and traditional. Just looking at all 800 scores, there is statistical significance between the scores for across gender. Okay, now let me show you how things actually kind of get kind of cool. So let's again look at our right here. Let's look at our values, and I can come over here on R, and I can create my model. And the way I put in a 2-way ANOVA model in R is I put in my Y, which is points. Oh, guys, hold on, get ready to mess up. I need to come back in and go back to my original data set. So I need to attach data, so make sure I've got all 800 subjects and not just one of my 4 data frames. And what I always do is I like to come in and just take one of the variables, points, whatever it is, and just do the length of it, just to make sure that that R is seeing all 800 subjects here and not just a subset of 200 of those. So if I want to do my model, I'm going to do AOV, and I'm going to put in my my Y, my dependent variable, and then I'm going to do gender across group. Okay? So what this is going to do, it's going to give me my two main effects, gender and group separately, and then it's going to look at the interaction. Now I can come in and do summary model. And gang, you're going to see a lot of familiar stuff. See the 45,030, which is the sum of squares for the gender, 168,432. We have 1794, and then of course the error term is 192 that we're given there, and our degrees of freedom. You can see 796. You can see the reason we were given 0 when we calculated 1 minus PF is this is actually what 0.000. Pretend I said 15 zeros 2, so it got tired of doing that, so it just told you 0. Now to calculate this one down here, for example, the interaction, the p-value, we would just go 1 minus PF. The F statistic is 7.409. My degrees of freedom are 1 and 796. Okay. Now when it does that, it's going to give you your p-value, out as far as it reports that we got right there. So guys, I hope you understand a little bit more. I could have just started throwing things at you, but I don't know. I think it's important for you guys, considering the nature of our program, to know more than just how to put things in R and punch a bunch of buttons. Now, something that's really going to be kind of helpful here is to look at our confidence interval means. And if you think about our means as they, for example, as they came for when we did t-apply, and we did points across gender and group, and we looked at our means. Now, we noticed that we have our means that range from 103 is the lowest, so I'm going to start this down around 90. Now let's go all the way down to 80. And then our biggest mean is 148, so I'm going to go up to about 180. So I probably can't make this work out right. But pretend I did. All right. Pretend that is the same as that. Okay, it's 10 units. Now what I can do is I can install a package called LSR. It's kind of cool. Maybe. And access its library. And by doing that, I can go up to t-apply, and I can come in with something called confidence interval for the mean. Well, that was lovely. Okay, that's not going to work. That's not going to work at all. What I have to do here is I have to use, I forgot all about this. I have to use the aggregate function here. So I come in still with points, but I'm going to do that over the sum of my two groups. Yeah, I forgot. And I've got to come in and tell it with data, and then I have to do CI mean. Yeah, all right, cool. So what I end up with is I end up with a confidence interval. Let's just start at the bottom from 102 to 105. And I'm going to start from the bottom and just call that 4. The next one, I go from 113 to 118. Now I go from 127 to 132, and then I go from 145 to 150. Now you can see that I get separation of each one of these confidence intervals, which makes me think that my interaction is going to be statistically significant. So guys, I'm going to end this video. I just wanted you to really think about the calculations, how we decompose the error, or how we get an error decomposition, how sum of squares for each of these are calculated, and just see that. Now, the fun in two-way ANOVA is when we start getting into the assumptions, we start seeing when things go wrong, what do we do when assumptions are violated, and you got to think about it. We have a lot of combinations when we get statistical significance from our ANOVA. First of all, we could have one effect significant, one not. We could have both effects that are significant. We could have an interaction that's significant or not in any combination with our main effects. So how do we interpret this and make decisions about, for example, instruction and gender, as we've seen in this generic example? How would we make heads or tails out of our... Now, I want to tell you one more thing before I leave, or I finish. I'm not leaving. How do you handle R? I don't know if you guys are doing this yet, but gang, I tell you what, you need to start an R notebook. I mean, get interactive in these videos. If you're watching these videos and you've got on Grey's Anatomy or Survivor or whatever, Fresh Off the Boat, Blackish, whatever you may be watching these days, to me, I would want to take a notebook so when I ran into something on my assignment, when I ran into something even as soon as your thesis, I wouldn't want to have to go back and look at the notes or at the videos and try to find the place. Where did he talk about that? And in the 14 videos we've seen over the past. I would want a notebook. So I would definitely create a notebook, or at least 4 or 5 pages in your notebook to do nothing but R commands. For example, this tapply over here, where you're trying to look at group means. I would hate to have to go to Blackboard, pull up a YouTube video, search through that. Maybe your internet connection's like mine, not very good, get a lot of stalling. I'd like to just have a place in my notebook where I can just go and say, hey, this is the way Darbro found means over the groups of 2 categories. So, and this is the way he carried out a two-way ANOVA. All right, gang, that's all I got. Take care.